Lester, Wushu Engineer. Right in the beginning of this video, I'd like to give credit to a YouTube creator, the YouTube creator who actually inspired the central idea for this project, unwittingly, and that creator is Skallagrim. He covers a variety of topics on his channel that includes weapon reviews, weapons testing and armor testing. So if you haven't already checked out his channel, I encourage you to check it out. His content is good. I really enjoy it. But while I was watching one of his videos a few years ago, it's a fairly old video in which he was doing some stab and cutting tests against a human torso analog. In these tests, the analog was clothed in what looked like a very baggy, loose-fitting nylon ripstop poncho of some kind. It was a long time ago, so I can't remember the details exactly. In fact, to be perfectly honest, I can't even find the original video to reference in this video. So for that, I sincerely apologize. You'll just have to take my word for it that it actually occurred, and you'll have to take my word as far as the details are concerned. During the tests, Skallagrim observed that the blade of the weapon that he was using against the torso analog was getting caught and kind of bound up in layers of the nylon fabric, and the fouled blade was then slipping against underlying folds of the material as he was trying to stab and cut with it. This phenomenon was interfering significantly with what should have been a simple set of cutting or stabbing tests. I remember that he noted this phenomenon and briefly discussed this as an interesting aside in his commentary. But the phenomenon really got me thinking. If this fabric slip behavior could be incorporated into a type of stab and cut resistant armor, it might be able to significantly improve the constituent material's natural cut and stab resistance. I thought that it may be possible to make a kind of reactive stab and cut resistant fabric armor. So I've been thinking about it casually ever since then. There are a number of designs that I considered along the way. Typically I work with designs in my head, often while I'm sleeping. So while I'm sleeping, I'm actually kind of building and testing things sometimes. Pretty weird, huh? Anyway, there were a number of designs that I considered, including a padded fabric made up of multiple layers of thin nylon, separated by some kind of light stuffing, like a sleeping bag kind of stuffing material. However, none of the designs seemed good enough to be functional and didn't really offer sufficient movement of the fabric layers. And that was one of the problems that I was encountering, is that somehow or other these various layers of fabric need to be held together into a whole, and this was of course impeding any kind of movement in that fabric. In addition, it was also really difficult to find fabrics that were strong enough to reduce the required thickness of the system. So of course, if you are trying to defend yourself against a weapon, putting any amount of a single material in front of you is ultimately going to foil the weapon, but we can't walk around with a mile of cream pie in front of us. So you know, it has to be functional in terms of its thickness and its weight. Aerial density is another thing that is very critical for things like ballistic armor. So I kind of put the idea on the back burner. In other words, I kind of forgot about it and then moved on with other things. Right up until after I uploaded my video entitled Stab Proof Fabric Armor, Ultra High Molecular Weight Polyethylene Felt Tested. For those who did not see that video, I encourage you to go and watch it because it provides some context to some of the materials that I used in this video. I'm not going to I've got a chorus of little green tree frogs that have invaded the door structure in my school. So I can't open the sliding door anymore because I don't want to crush the poor little things. And there must be like upwards of 4 or 5 of them that are permanently living in there. And sometimes if I talk too loudly, they think I'm trying to compete with them, and so they start up their chorus. Anyway, that's besides the point. So anyway, it's important that if you want to know some of the material characteristics here in more detail, that I would encourage you to check that earlier ultra-high molecular weight polyethylene video. In this video, I said the following. So I believe that there is a lot of potential for this material if it is modified in some way. And it only occurred to me a bit later on that the fabric slip phenomenon that Skallagrim observed in his tests may be just the kind of modification that the ultra-high molecular weight polyethylene felt fabric needed in order to improve its performance. As was demonstrated in the ultra-high molecular weight polyethylene video, this felt material appeared to be far superior to woven high tensile fabrics such as woven ultra-high molecular weight polyethylene and Kevlar in terms of its stab resistance. In this video, I suggested that the non-woven omnidirectional lattice of ultra-high molecular weight polyethylene fibers present in the felt material, along with its inherently superior thickness, were the source of its superior performance over woven fabrics. And in fact, in that video, I've actually got some filmed microscope footage of the various fabrics that I tested to show how the fibers are either aligned or not aligned at all, and omnidirectional in the case of the felt material. In this, so I thought that there may be potential to create layers of ultra-high molecular weight polyethylene fabric that could slip around on a layer of smoother material beneath it. However, if I just had a continuous layer of felt over layers of slippery material, it wouldn't really work very well for two main reasons. Firstly, large-scale pieces of felt would present a much higher surface area in contact with the slippery layer of material beneath it. That's much higher surface area in relation to the amount of fabric that was required to shift. So the larger surface area would increase the contact area between the two layers and thus increase the frictional forces between the two and potentially almost completely eliminate the potential for slipping to occur. Secondly, larger pieces of material would introduce more boundary effects where they are attached to or abut other pieces of fabric that make up the garment, because of course they have to be connected together in some way to form a garment, otherwise they'll just all fall off your body, and well, then you're going to have to hope that you've got your magical bikini armor underneath. These boundary effects would further impede movement of the fabric layers and thus further reduce the potential for valuable slippage. After some thought, I decided that a modified version of a typical LARP style fantasy leather scale armor might actually be the ideal design here. On a side note, I recently saw an article about a leather scale armor that is actually purported to be 2,500 years old, that was recently discovered, remarkably well preserved, in a remarkably well preserved condition, by the way. The interesting thing to note is that it is similar in design to your typical LARP leather scale armor, albeit more intricate. So I took this basic design idea and I modified it a little by increasing the length of the LARP leather scale armor, the LARP leather scales, until they were a little bit like longer strips or straps. Actually, they turned out to be very similar in appearance, a little bit shorter than, but similar in appearance to, and I'm going to mispronounce this, so excuse my pronunciation, but terugis, which Wikipedia describes as follows. Terugis formed a defensive skirt of leather or multi-layered fabric, linen strips or lappets, worn dependent from the waists of Roman and Greek cuirasses of warriors and soldiers, defending the hips and thighs. So like that little skirt that they would wear, the skirt made up of straps. In fact, it was while looking at these terugis that I considered that they may have been designed, at least in part, to function in a similar way to my proposed slip scale armor design that I was working on. That's what I decided to call it, the slip scale armor, instead of slip scale, slip scale. albeit the terugis were constructed, of course, with more primitive materials, like leather. There were some very smart people knocking around the world back then, so I could certainly believe that this kind of functionality would have occurred to them, and that it may have even been intended in that design. The layers or sections of continuous straps in my design would then be sewn onto a simple, continuous, ultra-high molecular weight polyethylene backing fabric layer, in such a way that they would be staggered. So they'd have one set of straps or tiles, or scales overlapping the others in a staggered kind of way, to provide maximum coverage and minimize weak points. So of course the strips would be separated, and it's at that separation point that it's a weak point. So you'd want the overlapping scale or strap or strip to be resting over that break between the two straps below it. The idea was that if a knife point was to make contact with one of these lengthened scales, that the scale or the strap would slip to the side and absorb some of that energy, and also interfere with the penetration vector to compromise the stabbing process. However, ultra-high molecular weight polyethylene felt is not very slippery at all, so the design needed something else. I originally tried treating the fabric with dry lubricants as a simple solution. That was a total failure and made a big mess to boot. So I finally opted for layers of a silky fabric sewn in between the layers of the scale straps. As long as I got the alignment of the silky fabric weave correct, this would provide a smooth surface for the ultra-high molecular weight polyethylene fabric straps to slide on. So let me show you what the final product looked like. So this is what the slip scale armor looks like. It has a single backing sheet of the ultra-high molecular weight polyethylene felt fabric, as you can see, and then roughly and agriculturally sewn on top. Excuse my sewing skills. There are these layers of what amount to almost like scale armor. So very similar to how you might construct leather scale armor. I'll see here is I've got 3 layers of this on this test piece, 1, 2, and 3. You'll notice that there's a difference in spacing between the 3. I'd like to pretend that that was done on purpose. So let's pretend that that was done on purpose. At the end of the day, it does allow us to test with different densities of these scales sewn on top. You'll also notice this black fabric, interspaced black fabric layers. This black fabric is kind of a very slippery, smooth, nylon-like, or probably more like a silk style, artificial silk style fabric. And I've aligned these in such a way that the weave runs in such a way that any material that rubs up against it experiences the least amount of friction linearly along that material, which will hopefully allow these to move quite freely if something embeds itself in them and then tries to shift them. So the idea is that these layers, which are also made of the ultra-high molecular weight polyethylene felt, act as little independently moving scales that, if a blade tries to penetrate, actually slip to the side and absorb some of that energy and potentially limit that penetration. Of course, theoretically, if the knife penetrates exactly at right angles, or normal to the surface, I should say, then there shouldn't really be any benefit at all. but the odds of a perfectly normal strike or stab occurring perfectly normal to this fabric would be extremely unusual and extremely rare, since it would be worn on a human body, which is by its very nature is going to be kind of curved a little bit. And of course there's movement involved in the person wearing the armor as well. So that would potentially also, especially if they're trained to move in such a way to best deflect incoming strikes, might actually work alongside with this, alongside this armor's basic functionality to improve its ability to thwart penetrations. As you can see, it's not very thick. It's actually quite thin. It's very light. These fabrics are very light, very flexible. So it'd be very interesting to see how this performs in the tests that I do. See if there's any benefit to this more nuanced layout of the, and use of the ultra high molecular weight polyethylene felt. Of course, it would be worn, I hardly have to explain that, but it would be worn with the scales, if you like, facing outward, the strap scales. So we'll see how that performs. Now, typically when I test armor samples, I use a weighted pendulum apparatus in order to standardize the impact force and energy to make the tests as consistent as possible. However, setting this apparatus up is a bit of a schlep, and since the slip scale armor was a completely untested prototype that could just fail at the gate, I decided that for this video I would just do some tests by hand. The main reason for not doing the full tests for this video is, of course, the time and effort required for an armor design that may not even work to begin with. Hence this video being titled Preliminary Investigation. I might also mention a technical detail related to the kind of apparatus used in stab tests that may differ from actual human performance, and which may be a little unfair on the samples being tested. This technical detail is that typically a rigid assembly is used to drive the blade into the sample, which allows for no flexure between the knife blade and the driving mass or the arm. This is an excerpt of the draft NIJ standard 0115.01 stab resistance of body armor published by the National Institute of Justice in March 2020. As you can see, this assembly is basically a constrained dropped mass with a rigidly mounted blade on the bottom of it. An assembly which does not allow for flexure of the blade mounting location at all. My pendulum apparatus is much the same in that the knife blade is rigidly attached to a pendulum arm. The reason that this assembly differs from a human being stabbed with a knife is that, a human being stabbing with a knife, I should say, is that at the point of impact, various joints in the human arm, most notably the wrist, will flex to a certain extent due to the impact force. These flexures can affect the attack vector of the knife blade by very small amounts and can thus counteract some of the stab's effectiveness, especially when encountering tough fabric or thick clothing. In fact, at some stage I'd like to do a video perhaps looking at some slow motion footage of a stab, potentially showing a little bit of flexure in the wrist as well. But that'll be a project for another day. A fixed knife blade, on the other hand, as used in stab tests, is not affected in this way. In my pendulum's case, for instance, it could be said to more closely resemble a 5-kilogram war pick than being a reasonable analog of a human arm wielding a knife. Now, although using these kinds of apparatus is good for standardization, and really we have to make some allowances in order to standardize these tests, and that's why it's acceptable to test in that way, it will still end up skewing tests by making them a little bit more arduous for the poor armor samples than might be expected from a typical knife wielder. I should also mention that in this set of preliminary tests, I used a bundle of clothing stuffed into a burlap sack as an analog for a human body. I am well aware that this is not a good analog for a human torso, but for the purposes of these preliminary tests, it was more than good enough to give us an indication of whether the slip scale armor concept had any potential merit as stab resistant armor. So that said, without any further ado, let's go into the testing and the show and tell afterwards. So instead of actually doing a full formal test using my pendulum rig, I thought that what I would do first of all is just to try some strikes against it just by hand. And to do that, I'm going to use this cold steel. I think it's the Commando Tanto. Anyway, I'll put the description in the link. I'll put the description in the video. The cold steel product, obviously with the Tanto point. I've used it in all of my other tests, of course attached to the pendulum. And I'm just going to, I'm going to be fairly light at first, and then I might up the ante a little bit. Just see what it starts looking like here. So that actually impacted one of the straps, the scales, which slipped up that way and didn't penetrate this fabric layer underneath. Try that again. So that was a little bit more substantial. It hit one of these scales again, didn't penetrate. Again, it's striking these scales, and I think it's slipping. It's not actually penetrating the first layer at all. I should mention that behind it I've got not the most amazing analog for a human body. It's really just a bunch of rolled up clothes in a bag, so it's not great. But this is just a preliminary test just to see if there's any value in the design. So I'm going to change my grip, and I'm going to start going from the side here a little bit and try to get a little bit of swing into it. So here I penetrated through part of one of these scales, and then it penetrated partially here, and then impacted on one of the bottom layers here and didn't penetrate that at all. Again, I'll try that again. So the time it slipped off one of these top scales, impacted the bottom scales, penetrated partially but did not go through. There's a tiny little penetration on the back end, possibly a millimeter or so of penetration. Try that again. Again, I'm kind of hitting in the same spot here. Again, it impacted this layer of scales, and I got again quite a small penetration, probably only about that much of the tip that penetrated the bottom sheet. Try striking in a different place now. Okay, so I can tell where that struck. Anyway, it didn't actually penetrate at all. This bottom layer here slid around quite a bit and redirected some of that energy as it should. So I think what I'm seeing is that when I'm striking at the lower level, which has the lower concentration of rows of scales, there is a certain amount of penetration, but it seems as I'll try another strike around the top here and see if that shows a similar result. Okay, so there you can see I got it on this scale here, which slid around an awful amount. Didn't penetrate anything at all. You might say that that's like a pinprick penetration there. Didn't go through the backing layer. So I think that's kind of what I'm seeing here, that this kind of concentration of rows of scales and straps is actually functioning quite well, to, at least with the setup I've got here with this analog, which is, as I said, not perfect, seems to be working quite well to dissipate the energy. A lot of movement in this, in these various fabric elements as I'm striking it. I can feel that movement, which is messing around with penetration angles and that. I'm hitting it quite hard. So interesting results, and maybe in a follow-up video worthy of a full test using the pendulum apparatus. I'll take this down and we'll examine it more closely using the other camera. Okay, so this is the armor sample after I performed the tests. What I noticed was that the most serious penetration, which is this penetration here, as we were discussing when I was doing the tests, actually occurred in this lower area here, which has a lower concentration of these tiles, not tiles, but the straps or scales. As you can tell, this arrangement here is far denser than the arrangement between these two. The other interesting thing about it was that the penetration occurred right between the scales, so the least optimal striking or penetration location, and it did indeed penetrate there. But in all other cases, you can actually still see some of the bumps from the impacting point here in this upper region. None of them actually penetrated this bottom layer in any real substantial way that would have caused any kind of penetrative injury to a person wearing this. Perhaps a percussive style injury, maybe a bruising or something. So that was really interesting, and as I was discussing while I was doing the tests, this arrangement was actually functioning. Actually, in one of the tests, one of these actually shot up while I was stabbing. Clearly, the angle was a little bit raised, so it was actually sliding up and absorbing some of the energy of that strike as it was doing so. Whereas in the other tests, mostly it was moving sideways on one of these slippery fabric layers. So yeah, very interesting. I just wanted to show you what the piece looked like after the tests. As you can see, the only real penetrations occurred here in this lower region that wasn't as well protected by the density of scales or straps. So I think this might actually be a very valid subject for a follow-up video. If there's enough interest in this one, I might pursue it and do a more comprehensive test using the pendulum apparatus, which is a little bit more dependable than human performance as far as these kinds of tests are concerned. As I mentioned when I first showed you the sample up close earlier in the video, it's extremely light, actually not particularly thick, something that could be worn as an undergarment underneath a t-shirt even. We just have two panels, one on the front and one on the back with some shoulder straps. Yeah, and while it's not perfect, and it's more than likely not going to stop any kind of attack whatsoever, or any kind of attack that comes at it, certainly better than most options, especially in terms of its weight and its its thickness and the fact that it can be worn as a normal garment. So yeah. As you can see, these informal preliminary tests indicate that there is some potential for this design. Although I did not put the design through my official pendulum tests, it certainly appeared to outperform the simple layered ultra-high molecular weight polyethylene samples that I was testing in my previous video. If there is sufficient interest in this video, I may consider going through the rigmarole of the full pendulum tests. So let me know in the comment section below whether you're really interested and keen in seeing a full official test done of this design. I hope you enjoyed this video, and I'll see you all again next time. Cheers!